This is section 2.5, looking at part C, which is a general factor strategy. So we're going to put all of our factoring strategies together. This first page right here is just a kind of reminder of the things that we need to look for when I'm trying to decide what my factoring strategy is. First, you always want to look for a GCF no matter what the problem looks like. If there's something in common, you want to factor that out first. After you've considered GCF, you want to decide how many terms that are left in the polynomial. If there are two terms, we really only have one strategy right now, and that is the difference of squares strategy. If it's not a difference of squares, it probably can't be factored further. If it has three terms, we have two different techniques. One of our techniques is for the coefficient a being 1, and that's when you just break down the last term, add it up to the middle term. And if a is not equal to 1, then you use two different strategies. Again, you can trial and error, or you can use grouping. So trial and error, or AC for grouping. So there are two possibilities in that case. And lastly, if there are four terms, then you're only going to have one possibility, and that's going to be grouping. Always make sure after you factor by one of these methods that you look at your factors to see if any of the factorables are factorable again. If so, go through your chart again, and if not, we're done. Okay, so we're going to look at the next page, which has looks like it has 4 problems that we just want to factor. Hopefully each of these is going to use a slightly different strategy. Oh, I forgot to put my page. There we go. There's my 6 problems I expected. So we're going to look at each of these 6, factor them, and then a page after this we'll see 4 more. So we'll do 10 altogether using the general factoring strategy to get them factored. Part A. We always want to look for a GCF, and I see one here because I see that all of these values can be divided. 10, 22, 24 can all be divided by 2, and they all have at least x squared. So we're going to start by factoring out 2x squared. That's going to leave you with 5x squared plus 11x minus 12. Okay. From there, I need to see if this factors again, so I can either use trial and error, or I can use the AC method. I'll choose AC method on this one. If I get another one like this, I'll use trial and error just to kind of be fair with the two methods. So AC, we take 5 times negative 12, which is going to give us negative 60. It's negative, so I know I need a positive and a negative factor. And because the middle term is positive, I know that the positive factor needs to be larger to be able to add up to a positive. Okay, so I start thinking of things that go into 60. The first thing that goes into my mind is 6 and 10. So if I did 10 minus 6, that would be 4. It's not going to work, so I try again. I also know that 60 is 15 times 4, and that would subtract to 11, which is what I want. So that's the pair I need. Leave your 2x alone, 2x squared alone, big brackets, and then we're going to separate. So I'm going to have my 5x squared plus 15x minus 4x minus 12. And I'm going to group. Okay? Leave your 2x squared alone. Big brackets, do your grouping. So the first two terms, 5x squared and 15x, have 5 and x in common. If I factor that out, I'm left with x plus 3. Second two terms have negative 4 in common. If I factor that out, I'm left with x plus 3. Again, because negative 12, negative 4 divide out to positive 3. Binomials are the same. So this is going to factor as x plus 3 times, take your coefficients, 5x minus 4 becomes the second binomial factor. Don't forget to drop your 2x squared down. So this becomes 2x squared plus 3x. 2x squared, times 3x. I can't even read. 2x squared times x plus 3, I mean to say, times 5x minus 4. There we go. So this one is factored. There were 2 strategies employed here. The first one was greatest common factor, and the second one was coefficient a not equal to 1. And because our coefficient a was not equal to 1, we can choose either trial and error or to use the AC in grouping. All right. In the next one, I immediately notice that there are 3 terms with no GCF. I can't factor something out of all of them. And because I do have a equals 1, a being the coefficient there, I have a equals 1, it means I just need to grab the last term and factor. If you wanted to think about it in AC terms, you're multiplying a times 21. A 1 times 21 is still 21. Okay? It's positive, so I know I need 2 of the same. They're going to have to be both negative if I'm going to have any chance of adding up to a negative 10. So what goes into 21? 3 and 7. So negative 3 and negative 7, that adds to negative 10. And because the coefficient is 1, there is only one way to multiply to a, and that's just with an a. One way to multiply to a squared, that's with a and a. I can just shove those right in parentheses. There is only one way to do that front piece. So I'm done. I don't have to group. I could group like I did over here. I did the same thing. I don't have to go through those steps. Oh, I have a small mistake here because I forgot about that b on the end. This is going to give me a squared minus 10a plus 21, but it's not going to give me the b's. To get those b's, I have to make this a 3b and a 7b. So let me make that little correction. Now, notice that you'll have a times a is a squared, a times 7b is 7ab, negative 3b times a is negative 3ab, adding to a 10ab, and then my 21b squared. Okay, if there's a variable in the last position, just don't forget it. It's going to have to stay in the last position also. Okay, I almost forgot it. All right, next one. Let's see, 2 terms. So I only have one strategy, difference of squares, but I got to look at GCF first. I see something in common. 24 and 54 can both be divided by 6. So if I divide out 6, that's going to leave me with 4x squared minus 9. Now, luckily for us, 4 and 9 are both perfect squares, so I can continue to factor. So I'm going to get 6 times 2x plus 3 and 2x minus 3. It's got to be those binomial conjugates, and I know that the square root of 4 is 2, the square root of 9 is 3, which gives me the 2 numbers I need to do my conjugates. Okay. Part D. Okay. So part D, we are going to try trial and error on this one because we tried the AC method last time. So if I try trial and error, I'm going to start with 2x and x as the only way to multiply to 2x squared. And then I have several possibilities for 6. 2 and 3, 3 and 2, 6 and 1, 1 and 6. So let's try 2 and 3. So if I do 2 and 3, it's got to be all positives, right? Because you need to multiply to a positive and add to a positive. So this one would give us 2 times 3 is 6x plus 2x equals 8x. So that one doesn't work. The next one, if I try 2x and x again, this time I'm going to try 3 and 2. They have to be positives again. And let's see if we got it this time. So it's going to be 2 times 2 is 4x, plus 3 times 1 is 3x, that's 7x. We skirted on both sides. We got 8 there, we got 7 there. We don't have 9, so that one didn't work. Okay, so let's try again over here. 2 and 3, 3 and 2 didn't work, so we're going to try 6 and 1. So what if it's 2x and x with 6 and 1, both positive? So it's 2 times 1 is 2x, 6 times 1 is 6x, that adds to 8x. Not working still. Last try. 2x and x, I tried 6 and 1, now I gotta try 1 and 6, both positive. 2 times 6 is 12. 1 times 6 is, 1 times x is 1, so 12x plus x is 13. That one doesn't work either. Now you've got to convince yourself that you've tried everything. There's only one way to multiply to 2, and that's 2 and 1, so I can't really rotate those. 1 and 2 isn't going to change any of these because I've been rotating the second coordinate. I only need to really rotate one of them, so I've done everything. 2 and 1. The only way to multiply to 6 is 2 and 3. I tried both 2 and 3 and 3 and 2. It didn't work. I tried 6 and 1, 1 and 6. That didn't work. I've tried every possibility for these numbers. This one is not factorable. In order to show that it is not factorable, that it really is prime, you need to show and cross off all of your attempts. This one is prime. It is not factorable. Okay. Part E. This one will be factorable. What I noticed, first of all, is although there are 2 terms, and although those are both perfect squares, there is something in common. So I have to factor out the 4 first. 4x squared minus 9, and then break it down. 4 is going to stay out front. 9 is perfect square, so you're going to get x plus 3 and x minus 3. Binomial conjugates again. That was a 2 terms with the difference of squares. That's how that one factors. Part F, you're going to look for a GCF because I see 14, 21, and 7 can all be divided by 7. And they all have at least an A and a B as well. So I'm just leaving with 2. Take out A, take out B. So 2AB minus 21 divided by 7 is 3. A is gone. There's a B left. plus 7 divided by 7 is 1, and the a's and b's are already taken out. Okay. I don't have any squareds left, so I have no hope of factoring this further. There's not quadratic anymore. So this one only had a GCF. That was the only thing I could do to get this one factored. So it's already factored. Okay. Last 4 examples. We are going to factor each of these. Check out our strategies some more. This first one has 4 terms, so there's only one possibility, and that is to group. So let's start grouping in the order they're in. Let's see. The first 2 terms can both be divided by x squared, so that would leave you with x plus 5. If the next term is negative, you always factor out a negative, and 9 and 45 can both be divided by negative 9. It's going to leave you with x plus 5. So the binomial in common is x plus 5, and the 2 coefficients are x squared and minus 9. So far I have x squared plus, I have x plus 5 and x squared minus 9. That's factored so far, but it isn't completely factored because x squared minus 9 is a difference of squares. I can factor that more. Because 9 breaks into 3 and 3, you can factor that as x plus 3, x minus 3. It's a binomial difference of squares I can factor into conjugates. That's one of my strategies. Now it's fully factored. So I had to factor again after I factored the first time to finish that one. Part B, GCF, first of all, both terms have an x, so you're going to factor out x. X cubed divided by x is x squared, minus x divided by x is 1. Once again, I only have 2 terms. It's also a difference of squares, so I can continue to factor. That's x times 1 squared is 1, so I'll have x plus 1 and x minus 1. Very similar to the previous one where I had my x squared minus 9. Okay. Now that's fully factored. It had to be factored twice. All right, and 2 left. They both have coefficients. See, this one has a GCF. No GCF. So they both have coefficients, so we'll do one by trial and error, and we'll do one by AC. So the first one, let's try trial and error on this one. And again, if you have a preference one over the other, try your way and make sure that you get the same answer as I do. So trial and error, there are several ways to break down 8. I could do 8 and 1, or I could do 2 and 4. I'm going to try 2 and 4. I usually try to do the 2 terms that are closer together and save the 1 whatever for a last possibility. Likewise, on 10, I usually save 1 and 10 for a last chance, and I try my 2 and my 5 first. So let's try 2 and 5. This is going to be negative, so I know it's 1 negative, 1 positive. I'm not going to put my signs in. I'll see if I can put them later if I can get the 2 numbers to subtract to 11. I know that the larger number has to be positive to get that to be a positive. So let's see what these numbers are. So the first one is 10n, and the next one is 8n. So it would have to be 10 minus 8, which is 2. That's not going to work. Okay, let's try again. 2n and 4n, but instead of 2 and 5, let's try 5 and 2. Okay, so this would give me 4n and 20n. I want the larger one positive, so it's going to be negative 4 plus 20 gives me 16n. It doesn't work either. Okay, so let's try again with 2n and 4n, but we will try 1 and 10. Okay, let's try. So that gives us 20n and 4n. Same combination as before, it doesn't work either. So 16n doesn't work. Okay, 2n and 4n, one more time. This time I can try with 10 and 1. That's 2n and 40n. Negative 2, because I have the smaller one, negative, larger one, positive. Gives me 38n. Doesn't work either. Okay, that's all possibilities using 2 and 4. I've tried 2 and 4 with 2 and 5, 5 and 2, 1 and 10, 10 and 1. So 2 and 4 don't work. Now I'm going to try all possibilities with 8 and 1, the other way to multiply to 8. So let's try 8n and 1n, and let's try 5 and 2. 5 and 2, so let's try, this gives me 8 times 2 is 16n and 5n, larger one positive, so if I do 16 minus 5, that gives me 11n, and we found it. Okay, so remember I needed the 16 to be positive, the 16 came from there, and the 5 to be negative. So my answer is going to be 8n minus 5 times n plus 2. Now, we found it through trial and error. It took me 1, 2, 3, 4, 5 tries before I found it. Had I chosen 8 and 1 to start with, I could have found it sooner, maybe right away. But that's not how it worked out. Okay, it doesn't always come easily when you're finding these. I do want to point out something. As I was going through these, anytime there's no GCF out of all 3 terms in the original, but there is a GCF in a parenthesis, like 2 and 2 will be divided by 2 here, or 4 and 2 can be divided by 2, or 4 and 10 can be divided by 2, or 2 and 10 can be divided by 2, these are automatically not going to work. So when I was doing this last one, because I was running out of space, instead of choosing 2 and 5 to start with, because I knew that the 2 couldn't go with 8 because they have a GCF, I chose the 5 first. Okay, so you can throw out many possibilities before you really work them through if you think about making sure there's no GCF inside the factor. Okay, so I could have thrown all of these away really quickly had I mentioned that or noticed that ahead of time. Okay, it had to be something that did not have a GCF inside either of the 2 factors because there is no GCF between all 3 terms. So just a tip as you move forward and try to use trial and error. In the next one, though, we're going to use AC just to give both methods a shot. Some people really hate trial and error, some people really hate AC, so I just kind of keep it fair. We get to do both. To start AC, I'm going to start with 16 times 25. 16 times 25, I think it's 400. I'm going to use my calculator for this. 16 times 25 is 400. And since 400 is positive, I'm going to need 2 of the same. It's going to have to be 2 negatives to get that to be negative 40. Okay, this one pops right into my head because I know that 20 times 20 is 400. That's going to give me negative 40. So I can get that one factored using negative 20, negative 20. So I'm going to have 16a squared minus 20ab minus 20ab plus 25b squared. Group. 16 and 20 can both be divided by 4, so I'm going to have 4a. It's going to leave me with 4a minus 5b. Minus 28 and 25 can both be divided by 5, and they have a b in common, so minus 5b. Divide out the negative 5, you're left with 4a. 25 positive divided by negative 5 is negative 5b. 4a minus 5b are in common, so we're going to get 4a minus 5b times the coefficients, which are 4a minus 5b. Those are the same, so to finally simplify, we can write it as 4a minus 5b squared. And that is the end of 2.5.